Welcome to Ask and Learn.
It is told that a hollow sphere is released from the top of an inclined plane. So first of all, I am drawing the diagram for this given question. So this is an inclined plate, and let the angle of inclination is theta, and a hollow sphere is released from this point. Let this is our hollow sphere. Now in the first part of the question, we have to find the minimum coefficient of friction between the sphere and the plane to prevent sliding. So we have to find coefficient of friction, that is mu. So I am going to show the forces in this system. Let the mass of this sphere, let this, that is m, and radius is r. So one is the weight of this system with this sphere, that is mg, that will act downward. So the component of this weight in this direction is mg sine theta, and let the friction force between these two surfaces is, that is F, and the component of this weight in this direction is given by mg cos theta, and one is the normal force, let this is N. So from force balance we can see that for sphere we can write that mg sine theta minus F, that is net force, is equals to, let the acceleration of this sphere is in this direction, that is A. So this will equals to ma. This is our equation first. And second is the torque equation, that is net torque is given by I alpha. So here torque is due to this friction force, that is F into R is equals to I is 2 by 3 mr square into alpha. From here we know that in pure rolling A is equals to R alpha. So alpha can be written as A by R. So put alpha in this equation and we get F is equals to 2 by 3 ma. This is our equation second. Now put the value of F in equation first. So put the value of F in equation first. So we get mg sine theta minus this is 2 by 3 ma is equals to m into a. From here we get the acceleration, that is 3 by 5 g sine theta. This is the acceleration of this sphere. Now we have to find the coefficient of friction. So from equation 2 we can write that F is equals to, this is 2 by 3 m into, now put the value of A, this is 3 by 5 g sine theta. We know that friction force is given by mu into normal force, and normal force is equals to mg cos theta is equals to 2 by 3 m, this is 3 by 5 g sine theta. From here we get the value of mu, that is 2 by 5 tan theta. So this is the answer of our first part of the question, that we have to find the coefficient of friction. Now in the second part it is told that the coefficient of friction in is the half of the value that we have calculated, and now we have to find the kinetic energy of the ball. So we have given that in this question mu is half of this, so this is 1 by 5 of tan theta, this is given to us. Now again I am using torque equation, that is net torque is equals to I alpha. So here not torque is due to the friction force, that is F into R is equals to I into alpha. Now put all the data in this equation. So F is equals to mu into normal force. So mu is 1 by 5 tan theta, and normal force is mg cos theta. This is into R is equals to I is 2 by 3 mr square into alpha. From here we get the value of alpha, that is 3 by 10 g sine theta divides r. Let this is our equation third. Now I have to find the acceleration of center of mass that is given by g sine theta minus g by 5 sine theta. This is from equation first. From here we get the acceleration of center of mass. This is 4g sine theta divides by 5. Now we know that angular velocity can be written as, that is, omega is equals to alpha into t. Now omega square is equals to alpha square t square. So now alpha square and t square is can be written as 2l upon acceleration of the center of mass. Now put all the data in this equation. So this is omega square is equals to alpha square is 9 by 100 g square sine square theta upon r square, and this will comes out 5l upon 2g sine theta. Now after simplifying this we get, this is 9 upon 40 into L into g sine theta upon r square. Let this is our equation 4. Now we have to find the kinetic energy. So the kinetic energy here is given by, this is kinetic energy is equals to, here two types of kinetic energy. One is the kinetic energy due to the translation motion, that is half mv square, and one is due to the rotational, that is half I omega square. Now put all the data in this equation. So this is half m v can be written as v square is equals to 2al. This is from equation of motion plus half I omega square. Now put the value of omega square from equation fourth. So this becomes half m 2 into L acceleration we had L already calculated, that is 4g sine theta upon 5 plus half I is 2 by 3 mr square, and omega square is 9 by 40 g sine theta upon r square into L. Now simplify this equation and we get, this is 4 mgl sine theta upon 5, and this will comes out 3 mgl sine theta upon 40. After simplifying we get 7 by 8 mgl sine theta. So this is the kinetic energy of the sphere, hollow sphere, when it rolls down to the bottom. Thank you.